Okay, what if the future of space travel wasn't about high-tech metals and circuits, but about ancient woodworking techniques? It sounds a little crazy, I know, but let's dive into the incredible story of LignoSat, where traditional Japanese craftsmanship is literally meeting the final frontier. I mean, seriously, could the future of space really be built from wood? It might sound like something out of a sci-fi novel, but this is a very real question being asked by top space explorers today. We're talking about replacing metal with timber in satellites orbiting thousands of miles above our heads. And at the heart of this whole idea is this little pioneer right here, LignoSat. It's a tiny 10-centimeter cube that combines cutting-edge space tech with traditional Japanese woodworking. And get this, we're talking about the same techniques used for centuries to craft the perfect sheath for a samurai sword. How cool is that? So you have to wonder, how did an idea this wild even get off the ground in the first place? Well, it all started with a really fascinating collaboration that's rethinking everything we thought was possible up in orbit. So what is LignoSat exactly? The name comes from ligno, which is just the Latin word for wood. It's the brainchild of a team-up between researchers at Kyoto University and the logging company Sumitomo Forestry. Their shared goal was simple but ambitious: to use a renewable, biodegradable material to tackle one of space exploration's biggest hidden problems. So what is that hidden problem? Well, it's the growing threat of space junk. And it's not just about all the clutter floating around up there, it's about what happens when that junk eventually comes back down to Earth. You see, most satellites are built from aluminum, and when their mission is over, they're designed to fall back into the atmosphere and burn up, which sounds fine, right? Except they don't just vanish. They release this fine dust of alumina particles that can hang around in the upper atmosphere and cause real damage to our planet's protective ozone layer. And this is a serious issue. As Japanese astronaut and aerospace engineer Takao Doi explains, these particles don't just go away. They linger for years. And with the explosion in satellite launches recently, we're creating a long-term environmental problem that we're only just beginning to understand. And this brings us right back to the crucial question: why wood? Well, it turns out this ancient material has some surprising superpowers, making it uniquely suited for the most extreme environment we know. To test the idea, researchers sent different wood samples like magnolia, cherry, and birch up to the International Space Station. For 10 months, they were exposed to intense radiation and wild temperature swings. And the result? No cracking, no warping, no decomposition, nothing. Turns out, in the vacuum of space with no oxygen to fuel a fire and no microbes to cause rot, wood is incredibly durable. The winner for its stability and strength was Honoki magnolia. And the construction itself is just remarkable. LignoSat was put together using sashimono, a centuries-old Japanese technique that joins wood with these perfect interlocking pieces, kind of like a complex puzzle. No nails, no screws, not even any glue. This isn't just engineering, it's pure artistry. So let's break down the advantages. On re-entry, wood just burns into harmless ash, unlike aluminum. It also naturally absorbs vibrations, which helps protect sensitive electronics. And here's a really key benefit: wood is transparent to radio waves. That means antennas can be placed inside the satellite, which reduces complexity and orbital drag. So with the concept proven on the ISS, it was time for the real test. It was time for LignoSat's first pioneering journey into orbit, all on its own. In late 2024, LignoSat hitched a ride on a SpaceX rocket up to the ISS. A month later, it was deployed, and for the next 116 days, it circled the Earth enduring the harsh reality of low Earth orbit. But the mission hit a pretty big snag. For its entire 116 days up there, LignoSat was silent. Ground control was never able to establish communication, which meant they couldn't get any data from its onboard sensors. It never called home. But, and this is a huge but, orbital tracking data confirmed the single most critical fact: the satellite held together. It didn't break apart. The wooden structure worked, proving that a satellite made of wood can absolutely survive in space. The core concept, a complete success. So, what does this hard-won success mean for the future of space exploration? Well, it means the story of wooden satellites is really just getting started. The team is already planning LignoSat 2. It's set for 2028, it's going to be twice as big, and it's going to have 2 independent communication systems to make sure it doesn't go silent again. One antenna will even be placed inside the wooden body, taking full advantage of the material's transparency to radio waves. That simple change could reduce drag and extend its mission by up to 50%.
But the ambition here goes way beyond just small satellites. The team's ultimate vision is to create an entire space timber industry. They're imagining a future where wood is a primary building material for much larger structures in orbit. As project leader Takawa Doi says, this could fundamentally change how we operate beyond our planet. It's a shift from a temporary, disposable presence in space to a truly sustainable one.
LignoSat proved that one of humanity's oldest, most sustainable materials might just be the key to our future in the stars. And it leaves us with a fascinating question. Are we about to trade the age of aluminum for an age of wood, even in the final frontier?